Let us now discuss how to graph the ellipse given its equation. Example number 1. Given the equation x squared over 36 plus y squared over 16 equals 1, give the coordinates of the center, foci, vertices, co-vertices, and then graph. Solution. Step 1. Analyze first the type of equation given. Since the equation does not have h and k, we know that it falls under type 1 or type 2 equation, where the center is at the point of origin, 0, 0. Next, we look at the denominator. Since a squared is under x squared, or the bigger denominator is under x, we know that its graph will align itself with the x-axis. Therefore, the graph is horizontal. We can now write the coordinates of our center. We have 0, 0. And the orientation of our graph is horizontal. Now let us solve for the length of our semi-major axis, or the value of our a. So the value of our a squared is 36. So to get the value of a, simply get the square root of both sides. And what is the square root of 36? We have 6. Therefore, the length of our semi-major axis is 6 units. Let us now solve for the length of our semi-minor axis, or the value of our b. B squared is equal to 16. Now, to solve for b, we just get the square root of both sides. So what is the square root of 16? We have 4. Therefore, the length of our semi-minor axis is 4 units. Lastly, we solve for the focal length, or the value of our c. The formula is just similar to the Pythagorean theorem. So we have c equals the square root of a squared minus b squared. Simply substitute the value of a squared and b squared. 36 minus 16 is 20. What is the square root of 20? We have 4.47 or 4.5. Therefore, our focal length is 4.5 units. Now that we know the value of our a, our b, and our c, and also the coordinates of our center, we can now sketch the graph of our ellipse. Now, since a represents the semi-major axis, and the value of our a is 6, we will count 6 units from the center to locate our vertices. And since the orientation of our ellipse is horizontal, we are going to locate our vertices in the left and right direction. So from the center, 0, 0, let us count 6 units. 1, 2, 3, 4, 5, 6. Our first vertex, therefore, is at point -6 and 0. Let us locate the other vertex. 1, 2, 3, 4, 5, 6. Our second vertex, therefore, is at point +6 and 0. Now, let us locate our co-vertices. Please take note, the co-vertices are always perpendicular to the direction of the vertices, meaning If the vertices are found in the left and right of the center, our co-vertices will be located on top and below the center. Now, to locate our co-vertices, we will use the value of our B, since it represents the semi-minor axis. Let us now locate our co-vertices. So 1, 2, 3, 4. Therefore, our first co-vertex is at point 0 and positive 4. The other co-vertex is 1, 2, 3, 4. Therefore, our second co-vertex is at point 0 and negative 4. Lastly, we locate our foci. This time, we're going to use the value of C, since it represents our focal length. Now, please take note that the location of our foci is always in line with the vertices. Since the vertices are located in the left and right of our center, we will locate our foci also in the left and right of our center. So from the center, we will count 4.5 units. 1, 2, 3, 4, plus 0.5. Our first focus, therefore, is at point negative 4.5 and 0. Let us locate the other focus. 1, 2, 3, 4, plus 0.5. There you have it. Our second focus is at point positive 4.5 and 0. Let us now sketch our ellipse by connecting all of the vertices. Presto! You now have the graph of your ellipse. Now, to complete our answer to the problem, since it is asking for the coordinates of the vertices, co-vertices, and the foci, we may also list them all in this manner. So, that's it. That's how we graph an ellipse with center at the point of origin. In my next video, I will share to you how to graph an ellipse with center at point HK. So I hope you have already subscribed to my channel so that you'll get updated when I upload my next video. Thank you so much for watching. See you next time. Bye!